All right, can you guys hear me in the back? Everything? Good. Cool. So as somebody already said, the presentation will be Fight Club themed. If you've never seen Fight Club, that's okay. It's not really that important. I tried to phrase everything in there in kind of a way that made it a little bit funny, but also I expect probably half the room maybe has never seen it. So it's not a prerequisite. You still feel free to leave if you hate Fight Club right now, but it's not a prerequisite. I'm going to skip the credentials slide. I assume you guys can look me up if you want to. I assume nobody really cares where I've worked or what I've done. What you really want to know is how you can create some better tests. So when do we run our tests? I don't know. Maybe some people run them all the time with auto test. Maybe some people run them only in a build, as in never run them. But a place that we often run them is after we've just made some changes and it's about time to check in. So that's what we're about to do. We're about to check in some code, and we see that our tests are running, and then we see this shit. And that's not great, but what we actually see is this shit. And the problem with all of this is that with failing tests, you only speak using profanity. So the changes that I made here were I have a movie domain object, and then I have a movie test. And I changed my movie domain object, and then I changed my movie test, and I ran everything, and everything was great. Customers should be happy. I have a new feature, ready to put it in production. But then I ran the test, and something failed, and it had what I thought was nothing to do with what I was working on. So now I'm pissed off, because I have no choices. At this point, I have zero choices. I want to check in, but I have to look at a test that I didn't write, that I didn't run, that may or may not help me, but I have no choice but to go work with it. So this is Bob, and Bob has bad tests. Unfortunately, Bob is also your teammate. Bob wants to do well. Bob wants to help you write good code. Bob wants to write tests that will allow you to refactor your code base and maintain your code better. But Bob doesn't know how to do that, because Bob is actually a pretty good programmer. That's why he passed your programming test to join your organization. Bob knows how to write good code, but he doesn't know how to write good tests. And unfortunately, Bob thinks they're the same thing. Bob left you this test. This test is not that complicated, but it's significantly more complicated than I would want to be left with. This test is currently failing. It's not very long, but before we can really even get into it, we have to already look at a loop. Who wants to look at a loop in a test? Bob decided that he was going to dry our code out with a loop in his test, so that's what we have, and before we can even really look at the meat of the test, we need to figure out what we're looping through. So we have customer's length. It's not that complicated. We know what that is, or do we? I mean, at this point, we don't. We have no idea. We have a failing test, and we know that we have customers. We have no ability to look at the failing test and figure out what's going on. We have to rely on our IDE, which gives us easy enough go-to definition, and cool, we have customers. Also, not really that complicated. There's nothing here that's absolutely terrible, but we've already relied on the IDE to take us somewhere to help us understand what's going on. And now we have to rely on the IDE again to take us somewhere else, because we don't know what a customer is actually initialized to. It's initialized in this magic method given to us by our test framework. If we're comfortable with this magic method, then that's great. But what if we're not? What if we're pairing with someone and we're mentoring them and they say, why does this magic method get run? Well, I don't know, because this is the way we've been writing tests forever and nobody stopped to say why. So here we have a setup method, and we're initializing the David customer and the John customer and the Pat customer and the Steve customer, and then we're putting them all in the customers array, which you already know. That's what we're going to use in order to loop through. So we're not going to look at the object mother, because let's not dig that far down, even though that's kind of the point of this. Why do we have to dig that far down? But we only have 50 minutes. So back to the failing test, looping through customer instances, we can finally get to our expected value. So we have a failing test. We've already had to navigate to a Java field and to some special helper method just to get through the loop, and now we're at our expected value. And we, of course, can't tell what our expected value is either, because it's using another helper method. So if we're going to go to a helper method, we have to first initialize the args. Step one is just figuring out what that argument is. Again, we have to use another go-to definition. We can't work within this test. I mean, I hope this is as painful for you guys looking at as it is for me presenting it. These tests are terrible. I rehearsed this presentation in front of my wife. She's like, can you maybe not give this presentation so angry? And I was like, I can't. These tests make me angry. So, sorry, I'm probably going to be angry for a little while. We have another helper method that we have to go into. This helper method doesn't even do anything that interesting. It's doing a little formatting. It's taking some strings and rental objects, and it's just putting everything together. And we don't even have time to talk about the law of Demeter violation, because these tests are so bad. So imagine we're working with these tests. We just want to check in our movie change, and we're down inside 2 helper methods looking at a law of Demeter violation, basically thinking like, all right, I might need to look for a new job. I can't work like this. That's what I would be thinking anyways. So we'll just ignore that for now, and we'll understand that rental info loops over rentals, returns a string describing a rental. It's not that bad, I guess. Back to the statement, what's next? Well, we have the customer object that we're looping through. Okay, that's not that bad. Ignoring the fact that we have no idea if we're Dave, Pat, or Steve, but at least we know what this object type is, even if we don't know what instance it is. And finally, we can get to a concatenated string. That's not bad-ish. So we go into the expect statement, and what does it do? It takes the customer, it takes a few strings, and it formats everything together. That's it. All it took was all of this code for us to understand what's going on in that test. We had a failing test, specifically the movie class changed, the movie test also changed, everything worked, we knew that our code was working, but instead of being able to check in, we had to look through all of this code that's for a customer class. Does anyone in here think that's a reasonable thing? We shouldn't have to do all that, and there's a better way. But before we get into the better way, we have to say, well, all right, so Bob wants to help us. Bob wants us to write better tests. Bob wants to write better tests for us. He wants to help us write maintainable code. What can we say about what Bob's done? Well, he used setup. It's commonly approved in our industry, sadly. But you can't really blame Bob for that. He read that he should dry his code out with setup, and Bob dried his code out. And he used object mother, so he kind of hid away his object creation somewhere. Again, just applying dry. Maybe that's good, maybe it's not. I'm not here to actually tell you that it is good or it's not. I'm here to ask you, why are you doing this? Are you just blindly applying it, or is there a better way? So I would say where it fails is, I would like to quickly understand this test. So I'm checking in. I want to quickly understand what's going on with this failing test. Maybe that failure was actually helpful, but going through all of those steps was not helpful. Specifically, so I had to find the statement test to start with, then I had to find the definition of customers that we're iterating through, then find the assignment to customers, then I had to digest the setup, then I had to look into object mother, which I didn't even bother to take you guys through. Then I had to digest each different customer instance creation within the object mother. I had to do all of that before I understood the first line of the failing test. That is entirely too much complexity for you to have to look through to understand the first line of a failing test. Then you have to digest the expected value being created by calling a method with a string, a customer, the result of calling rental info with 2 string instances, and blah, blah, blah. Find the rental info method, determine what its value is, digest the rental info method that's creating a string and returning data. And now you've mentally resolved the args to expect statement. You had to do all of that, 10 steps to simply understand what's going on in this test. And 0 characters that you have read so far help you in production. That's 0 value to your customers, 0 value to your business. You have done nothing but resolve the expected value of a test. If this were Fight Club, this would be the point in which he says, I want you to hit me as hard as you can. No one character that you've digested will run in production, not one. We spent all this time, we're 8 minutes into the presentation, not looking at one character that would ever be run and help the business in any way, aside from regression. It's also practically impossible to fix this test without some more code, more programming. How do you know what's failing and what's passing, which is also helpful, without looking at the loop and either putting a debug statement in there to know where things break, or without putting some console write line in there? You have to write more code or rely on the editor to give you a breakpoint or something. You can't even use this test to figure out what's gone wrong. So why? Why do we do this? Why do we put ourselves through this? We used to write code without tests. And then somebody said, hey, you can write these tests and they'll give you confidence. And you started going home at night not thinking like everything is going to fall apart and they're going to fire me. You started going home with some confidence. And that was great. But we just apply the traditional programming patterns to our tests, and we never step back and say, is this code different? What's different about the code? Is a test really the same thing as production? Should we dry it in the same way? What's our motivation for doing all of these things? We write tests we don't need with time we don't have to satisfy people we don't like. What if we took a step back? This is the happy place from Fight Club. What if we took a step back to our happy place where we had no code, and that's all of our happy place when we have no code to worry about? take a step back and we say, all right, what can we write here to actually help the business? Every line of code has an ROI, a return on investment. We only really want to care about the stuff that's valuable, the stuff that actually brings the business some type of value, brings the team some type of value. So what if we took a step back and we said, you know, maybe drawing everything in the exact same way is not the appropriate solution. Maybe I need to look at my tests in a completely different way. So again, it comes down to why. What motivates us? So let's say, for the sake of the talk, that what motivates Bob is he wants to enable refactoring, wants immediate feedback, and he wants to break the problem up into smaller pieces. I would say Bob succeeded in enabling refactoring. Bob gave us some tests that cover the domain, and I can change things around and verify that everything works. I get the immediate feedback of the tests. Fantastic. Bob failed absolutely terribly at breaking up the problem into smaller pieces. We have so many things tied together in this test that it took us 10 steps to even figure out the expected value. That's a ridiculous amount of coupling. Josh Graham, you may know, that's his Twitter handle. I once said to him, why are you writing tests? Why do you even bother to write tests? And he said, to create a tiny universe where software exists to do one thing and do it well. I think that's my favorite explanation for why you write tests. You want a tiny, tiny universe to work within, and you want confidence that whatever you're testing works as you would expect. I mean, software systems are large. They're complex. There's no way that we can really get confidence around the whole thing with a couple different tests. We need to break things down and test them individually. So we're going to keep that in mind, and we're going to think about how we can still have a tiny universe, but also we can apply dry. It's not like we should just throw dry out the window. It's valuable, but how does it apply to testing? It's maybe not the same as production code. So these tests were dry, of course. We used a helper method, and we repeated as few characters as possible. Thank God, because characters weren't on sale, so we had to save as many as we could. Did you feel that does anyone here feel that the application of dry helped you quickly understand the failing test? I keep waiting for someone to say yes whenever I ask that question. I mean, there must be someone, and it's okay. That's actually part of this. There are 3 levels that you can apply dry. And some people want to apply it at all 3, and that's great. If you ask yourself why you're writing a test and why you're drying it the way that you are, and if you come up with good reasons for all of it, maybe you're a 2-person team. Maybe both of you like tests written in that way. Maybe you don't mind looking through all of that code before you understand what's going on in a test. That's fine. As long as you consciously make that decision, go for it. I think there's a better way personally. I strongly suggest that you change your approach. I recommend applying dry at the suite level, so globally. Let's say that you want a customer. Use the test builder pattern and create your customers with test builders. Let's say you want a movie. Use the test builder pattern. Okay, great. Now in my customer tests, I can follow this builder pattern. It's a global reuse. It's dried up. Fantastic. I want a movie. Same thing. So I have this common understanding of code that's going to be used across the test suite instead of just at the fixture level. The problem with Bob's tests were all of his application of dry was at the fixture level. That rental info method is never going to help him elsewhere. The expect statement is definitely never going to help him elsewhere. So we have all of these helper methods that aren't really helper methods. They're just kind of like hiding your shit in the closet. I'm just going to put these characters over here and pretend like everything's fine, but it's not fine. You've made things worse for your team. Obviously, I don't think I really even need to get into drying things at the test level. That just makes sense. You want to dry things within an individual test, and you want to dry them throughout the whole suite. But maybe don't try to group your tests together. I mean, so Pat's a customer, Steve's a customer, John's a customer, and yet none of those tests collaborated in any way. But all of those tests carried the conceptual overhead of creating all 3 customers. So you've created all 3, never used them in any way whatsoever, but you've required maintainers to try to understand that, to verify that they're never used. It's a waste. There's a better way, in my opinion. I would approach the same tests. I would say don't test diverse customers at the same time. If you're not going to test diverse customers, then don't create them at the same time. Don't extract single methods for a single string return value. Do create data where it's needed, not part of some special framework method. There's no rule that says you have to use setup. Just, in my opinion, just stop using it completely. If you enjoy acronyms, and what programmer doesn't, I think you should write tests that are dry at the suite level and dry within the test, but focus on the test itself being DAMP, a descriptive and maintainable phrase, or descriptive and maintainable procedure. Whatever you're looking for, you want something that you can go to This test is failing. Okay, ideally, everything you need is right there within that test. We don't have to rely on an IDE. We don't have to jump around and go anywhere else. Everything that's failing is right there. The next best scenario is everything that's failing is here, except there's a couple global patterns in here that go in this maybe factory that creates all of our objects. Whatever, there's some type of global pattern that you use. But it's something that when you go to, it's not completely unfamiliar to you. It's not foreign. It's something that you've seen before. It's a pattern that you already understand within the test suite. So how do we go about doing this for Bob? The first thing we do is we replace the loop with the individual test. I mean, this is as obvious as it gets. So we break the loop, break all of these customers out of the loop, and we have more characters here. That's fine. Each individual test has now become simplified. Now when things fail, we actually have results we can use. Instead of one loop with one failure, we have 3 failures, and we have 1 passing test, which also gives us some information on where things have gone wrong. So we know which customers cause problems. We know which customers are not causing problems. Creating all of this is what some would call duplication. I expect there are many people in the room that probably feel uncomfortable with all of this. That's what people would consider duplication. But this is just step 1. It's only after we've duplicated everything that we're free to try anything. So the next thing you want to do is expect literals. Here's how the tests look now, and you have to ask yourself why the hell we're calling a helper method to create a string. I don't understand why anyone would ever want to call a parameterized method once that does nothing more than return a string. You know what the best representation of a string is? A string literal. That's it. There's no better representation of a string than a string literal. So obviously this is what you're looking for. You don't need to call a helper method. It's okay. You can spend more characters. I'm here to tell you it's absolutely okay to spend more characters if it makes your tests more readable. Next thing you want to do, as I said, is inline the setup. So here are the tests again, and they're fine. We've saved some characters by shoving everything in setup. But they still require us to go to definition, and that's kind of a pain. I mean, what did we really save here? We have a shorter test, but it requires us to go somewhere else to figure out what's going on. That's not a good trade. So these are the same tests, but everything's in line. Creating instances of David, John, Pat, and Steven setup moves characters out of the individual test methods, but it also increases our conceptual overhead. And there's really no valuable reason to do that. So here, we take out that indirection, and we put everything where it belongs. And this also gives us the ability to completely delete both the setup and all of the customer fields. So deleting code, always a good thing. Less to maintain and manage. So setup is clever. Bob's tests are very clever about applying dry, and I'm here asking how's clever working out for you. Do you feel like the aggressive application of dry is making the tests easier to understand, or is it making it more complicated? I mean, we would maybe apply this exact same approach to dry to our production code, but that doesn't mean that it just should be blindly applied to our tests. And the interesting thing is that despite replacing the dry tests with the damp tests, the overall number of lines is exactly the same. Exactly the same. The number of lines did not go up. Once we took dry out of one area and moved it to another area, and we made our code more clear, we got to delete a bunch of helper methods, it didn't change. The number of lines is the same. So we can create more clear tests without even increasing our character count or the number of lines we have to read. It's obviously a good thing. So we spoke previously about motivators. There are several motivators, not all of them good. So we want to validate the system. This is probably a good thing. We want to get feedback from the system. We want to prevent regression. These are all kind of synonyms. Maybe we want code coverage. Some people want 100%. I would say that's probably not a great idea, but it could be the motivation on your team. Maybe you want to enable refactoring. Obviously, a good reason to write tests. Documenting the system. I personally have never written a test to document a system, but some people love this, and that's great. If it makes you more effective, it's a fantastic motivator. Go for it. As I said, not all of them are good reasons, but I mean, I'm sure somebody in the audience doesn't even really believe in unit testing or has had a lot of pain with unit testing, and they have that manager that will not let them get away from it. They want to know why DHH and other people are telling them that unit tests are dead and tests should go away, and they have so much pain, they don't know what to do, and their manager won't let them let it go. This is not a great situation to be in, obviously, but that doesn't mean that you should just suddenly say, like, well, I'm going to kind of ignore unit tests, or I'm going to do something different around unit tests, or I'm going to write bad unit tests. Understand what your motivation is and then how that can impact your unit tests, and then write them in a better way. I mean, realistically, if you don't believe in unit tests, but your manager requires you to, first of all, if he's never checking your code, he or she is never checking your code, then you can probably not even ever write an assertion, and then everything will just pass and everything's fine, right? And if they are checking it, then it's in your best interest to write the most maintainable unit test you possibly can, right? If they're checking the code and you don't believe in it and you never want to look at it again, write the most maintainable test you can so that it never fails. And then you never really have to worry about it. TDD is probably the most common reason for writing unit tests. You want to break up a problem or improve your design. I think those are pretty much synonyms. Customer acceptance. I would never advise anyone to do this, but I once worked on a project and we had to have a green test suite before the customer would sign off on any feature. So we would go to the customer and say, we would like you to sign off on this. And she would say, okay, manually test it. Perfect, looks good. Okay, show me the green screen. You just open, or you just go to the web page and say, here, it's green. Okay, check it off. It doesn't make any sense to me, but it's a motivator. It's going to happen to you possibly at some point in your career, so it's worth understanding. All right, in that case, so now if these things ever go red for any silly reason, we don't get sign off and we have to talk about it, we want to approach our testing differently in that case. I suggest talking to the team, everybody coming to a shared vision of why you're writing the tests. Tests can be written for many different reasons. Assuming that a test is necessary is not necessarily the right thing either, right? TDD is a fantastic technique. I don't use it all the time. I probably use it 20% of the time right now, to be honest. I'm more of a fan of using tools kind of for where I think they're going to be the most helpful. So I do a lot of experimentation with REPL-driven development these days and much less TDD. If I were still working in Java all the time, then I would probably do more TDD. But apply these things in ways that help you, but also ask yourself why again. So let's say I'm working in Java, and I want to get all of the benefits of doing TDD in Java. And so I'm doing my TDD, right, and got a bunch of tests. Don't just commit that and walk away. You're not asking yourself why at that point. I mean, why did you write them? Because you wanted to do TDD, and it helped you improve your design. It helped you write better code, and that's great. You had a reason why, but because it helped you write the domain code doesn't mean it will help you maintain the domain code. So take a step back and look at every test and say, why do we have this test? If it helped me design code that is now designed, and you have no other motivator, then the only correct choice is to delete that code. Any fool can write a test that helps them today. Good programmers write tests that help the entire team in the future. If you remember nothing else from this presentation, this is what I would like you to take away. It's so easy to write a test that helps you in the moment for your current problem. It's one step harder to think about helping yourself in the future. You come back in 3 weeks, 3 months, you look at that test again. Is it written in a way that's going to help you maintain the code? And if the answer is yes, great. Now go on to step 2. Don't stop. Go on to step 2 and say, if I've never seen this code before, and I come to this, put yourself in your teammate's shoes. If I come to this test, is it helpful? Don't stop until you can also say yes. And that means looking at the failure, not just the pass. Look at the failure. What does the failure message say? If it just says, expected something was false, that's not really helpful. That doesn't tell anybody what's going on. Maybe the string describing the test. If you have a test name, maybe that's helpful. If it's not helpful enough, again, if you come to that completely blank, as we came to these tests at the beginning of the presentation, if it's not helpful, change it. Think about your team. So what can we do? Some specific concrete examples. It's pretty much what this presentation is about, is concrete examples of all of this. This is your career, and it's ending one test suite run at a time. How fast is your test suite? Who in here has a test suite that runs in under a second? Come on, really? Okay, I won't ask about 10 seconds. How long does your test suite take, Aaron?
About half a second.
Yeah, so that's where it should be. If your test suite takes longer than that, people aren't going to run it. People aren't going to run the test suite before they check in because their career is ending one test suite run at a time. Nobody wants to sit there. I mean, what do you call that time while your test suite is running? I call it waste because I'm on Twitter or I'm on email or somewhere probably worse, to be honest. I mean, we're not working. We're wasting our time looking at who knows what on the internet. So make your tests run faster. The easiest way that I know how to do this is to create solitary unit tests. So some people just call this a unit test, but other people call many other things unit tests. So when I was writing a book on all this stuff, Martin Fowler said, just stop trying to steal the phrase unit test. They're never going to let you steal the name unit test. Come up with something new. And thus, solitary unit test, it's pretty simple. Never cross a boundary. So your test suites are slow because you're hitting the database. You're going over the network. You're going to the file system. That's really what's slowing everything down. It's not like the internal computing is slowing everything down in most cases. So stop doing that. Write solitary unit tests that never cross boundaries. But a thing that's also very annoying is cascading failures. You change the movie class, the customer test fails. That's annoying. That's not going to help me get through my day faster. That's not going to motivate me to be excited about being on this team. Cascading failures take away my motivation to be a software engineer. So the class under test should be the only concrete class found in the test. That's it. This is the full definition of solitary unit test. And I actually have no examples of stopping something from going to the file system or stopping something going from the database, because I think that's pretty self-explanatory. You can write solitary unit tests that don't cross any type of boundaries.
Question.
Yeah.
Concrete you mean production versus concrete and abstract. I'm just not sure what's good with concrete.
By concrete here, I mean mock or stub. Yeah, I have some concrete examples. So we need some type of other phrase, right? We have solitary unit tests. We need something to say what the other tests are, because those are valuable also, and those are sociable unit tests. It's that straightforward. So as of now, we have vastly improved sociable unit tests. But we have multiple, what I was calling concrete classes. We have the customer test, talking to the rental, which talks to the movie. Any change to movie is going to cascade to all of those other classes. So what we have is better, but we're still entirely sociable. We have no solitary unit tests at this point. And I believe a good mix of both is really what we're looking for. We're looking for some type of, actually as much coverage as we can get from our solitary unit tests, because they're fast, because they don't go over the network, because they're not flaky, because they focus with one concrete unit test, or one class under test, and some mocks or stubs. So this is what we have right now. In my opinion, this test is already a pretty solid test. This is a great test. This test fails before I check in, and I know that I have a customer with a rental, with a movie that is a new release, and I can read an expected value without navigating anywhere. I mean, it's almost heaven compared to what we looked at in the beginning. So this is great. But the problem is, again, if a movie changes, then this test could fail. And we don't want this test to fail, because this is, it doesn't say customer test class, but this is in the customer test class. So we don't want our movie changes to break things. So this is it. This is a concrete example of using, I would just call this a stub, to be honest, but I'm working with Mockito, and they call it a mock. I don't think the semantics here are really important. But we're working with not our rental class. We're just working with a mock. And so any change at this point to a rental or to a movie will not cascade back to our customer tests. And you may have noticed the null, and you may have thrown up in your mouth a little bit. To me, this is the same thing as Godfather, right? We have a magic string in there that says Godfather 4, and then we have a magic string in there that says null. What's the difference between those characters within the context of this string? I just feel like as programmers, we just have this gut reaction of like, oh, why does he have a null? Oh, it must be a mistake. I mean, I'm sure there are people in this room who definitely looked at that when I put it up and went, oh, he made a mistake. He left a null in there. But it's just a magic string. It's a magic string on both sides. So what's the difference between null and Godfather? But OK, there's still going to be people that take exception to that, and that's fine, because you have a stub, and you just add some value in there, add Godfather in there, and move on. I'm just putting this up here so the people who feel comfortable with null will get some validation. Be like, it's OK. So we also have solitary unit tests that focus exclusively on summing. This old test, let's go back real quick. This first test on the left, it has string building. It has summing. It has a lot of different things happening. This test is covering many different things, and you don't necessarily need to. Here, we can focus exclusively on summing. So we have a mock rental that we're setting the charge for on the left, and we have a mock rental that we're setting the charge or the points for on the right. And then we set up our customer, and we just validate the value. These are beautiful tests. These are tests that you can come to with never having seen it before. None of you have ever seen this test before. And if this is failing, you know exactly what's going on. It's completely straightforward. You don't have to navigate anywhere. I mean, maybe you have to navigate to the builder. If this is your first week on the team, first day on the team, maybe you've never seen a builder. But we use these builders globally throughout all the tests. So even if it is your first day, you navigate to the builder, you see what we're doing. Oh, we're creating some instances, no big deal. Cool, for the life of the project, you now know what we're doing when we're creating instances and tests. You know that we're using builders. You can reapply this value. Even if you had to spend that time on this first test, you can now apply that across the whole test suite. So we lost some coverage. You know, we had a null in there, and we broke out our summing, and we lost the corner case tests that we were doing on the movies. Now we get it back. Well, what's nice about this? So now we have confidence in our fine-grained customer tests, and we have confidence in our movie tests, and we have all of the coverage that you had previously seen. Summing of points is tested. Summing of charges is tested. String building is tested. But also all of the domain cases for the movie class, all tested. So we have complete confidence in our system. But we also gained isolation, something that we did not have in any way whatsoever. We no longer have cascading failures. Specifically, any change to movie will no longer fail that customer test. Extremely valuable. When we run our tests, we know anything that's failing is actually failing because of a change in that domain class, as long as we're talking about a solitary test. This should be great. This should make our lives better. But we're missing integration, right? That's the one thing that we don't have. We have great isolation, fantastic. We have speed, fantastic, but we don't have integration. And that's why you should never choose one of these approaches exclusively. Choose the tools that make you effective. And that means a little of some over here and a little of some over here. That means for me, 20% TDD these days. I'm still using it. I don't have to make an exclusive choice to TDD everything or nothing. The same thing applies here. This is a sociable unit test that brings everything together. So now we have our tests that don't cascade fail. We have our tests that don't take a long time to run. And then we have this, brings everything together. It's got a customer named Pat with a rental, with a movie that's a new release, and another rental that's Scarface. You get the idea. We have one customer with multiple rentals, multiple movies, and we can tie the whole thing together. And there's no nulls to make anyone uncomfortable. So how else can you improve the test suite? One assertion per test. I know there will be people that take issue with this. I'm here to make my case, but then ultimately it's up to you on what you think is more appropriate. So this is, again, the movie test that we already saw. Let's say the second assertion fails. This is what you're going to see. I mean, I was going to say, what do you think? But you know, everybody knows. This is what you're going to see. One failure. 5 assertions, 1 failure. What's the value of the third, fourth, and fifth assertion at this point? It's 0. It's worthless. Maybe it's passing. Maybe it's failing. We have no idea. Code didn't execute. So you know of 1 failure, and you have 0 automatically generated feedback from the other tests, from the other assertions. Given a test with multiple assertions, when they are all passing, they all provide value. I mean, obviously, they're all passing. Fantastic. Life is good. You wrote that test, they all passed, and you thought, moving on. But then that first assertion fails, and it has completely voided the value of every other assertion. They're just worthless. They might as well not even be there. They're maybe worse because they're noise. They're providing you no value. They're sitting there, and they're giving you nothing. So in effect, they're noise. It's negative value. When you're faced with a failing test that has multiple assertions, you're forced between 2 shitty situations. The first situation is reading all of the test and then reading all of the domain and deciding that everything's fine. You know, assertion 2 failed. All right, let me figure out what's wrong, fix it, cool. All right, now 3, 4, and 5 are there. What are my choices? Read everything and make sure it's all right? Of course not, because we're all lazy. We just click run again, and then 4 fails, and 5 is worthless. And we go fix that, and then we run it again, and maybe 5 fails. We just go through this sad loop of running, fixing, and it doesn't have to be that way. What if we got all of the data that we needed at the same time? What if everything failed when it was supposed to and passed when it was supposed to at the same time? Wouldn't that be more effective? Well, the way that you have to do it is just break these assertions apart. Just don't use multiple assertions. It's not really that complicated. But part of this is obviously, well, I don't want to repeat too much code. Okay, cool. Use builders. Use some type of global dry application that allows you to quickly create your tests. If you can't quickly create your tests like this, break things apart into a single responsibility, there's another problem. It's not multiple assertions versus a single assertion. There's some type of other problem. You can't create your domain classes easily enough, or something. You have some other problem. Don't hide that problem by using multiple assertions. Instead, do this. So once we have this, now we actually see this. So this is much better. Now we have we have additional info. The exact same assertions, but now we have additional info. We can see that the first failure is for 3-day, the second failure is for 4-day, the third failure is for 5-day. We can also see by looking at the expected values that every single expected is 1.5 less than the actual. So just having all of that data at the same time would be better. But now we also have a pattern that we can work with. One assertion per test allows us to get the expected values and the actual values for every single test, which is clearly better, having all of that data at the same time. But now we have a pattern. What do we recognize from those failing tests? Anything above 2 days was failing. Everything that was failing was off by 1.5. So the sum of those failures had more value than the parts. So break your tests up into multiple assertions. Wrapping all this up, the tests you own end up owning you. It's another cute little quote from Fight Club, but it couldn't be more true. Every line of code you write has some type of return on investment. It's either positive or negative. Maybe it's flat. But more than likely, it's positive or negative. You have to own every single line of code in production, but also in your tests. So look at your tests from an ROI perspective. Let's say, for example, you wrote some code, you TDD'd some code, and it's going to change the color of a background on a website. This is not crucial to your business. But you TDD'd it, fantastic. It helped you create the good design to change this color, fantastic. You've done everything right. But then let's say the test is a little flaky. It fails now and then. Maybe there's a race condition because of the framework that you're using, something like that. Delete that test. Get rid of that test immediately. If that background color doesn't change correctly, your business will go on. Someone will complain at some point, and you'll fix the background color, and the user experience will be a little off for a little while. It'll be a little bit disappointing, but business goes on. But all of the time you waste on that flaky test that's just making the user experience that much better is a complete waste to you, to your team, to your teammates, to the business. Look at your tests in terms of ROI. Another example that I like to go back to is you have an insurance company, and the insurance company needs to look up all of its customers by social security number. You should probably have a validation on that social security number. You want to get that SSN right. You need to be able to look someone up. But that person has a first name, and maybe you put a little test in there to make sure that it's all alpha that comes through, because it's nice, It'd be nice to get the customer's name right. But you don't need the customer's name to be perfect to bill them. You don't need the customer's name to be perfect to contact them. You can look them up. Someone calls the call center. If I get your name wrong and you call the call center, everything's going to be okay if there's an extra 1 in there or something like that. So if you can write this test easily and maintain it easily, then do it. But if this is, again, a flaky test or a problematic test, what's the real value to the business? I mean, really, keeping that 1 out of someone's first name, what's the real value to the business? It's not very high. Stop thinking about your tests from an individual point of view. Stop thinking about them from, okay, I like TDD. I'm going to write this test, and that's it. That's the end of what needs to be done. Commit. It's not good enough. Start thinking about it from your team's point of view. You wrote that test, and it helped you get good-looking code, and that's great, but that's not a good enough reason for it to live on. What you need to do is look at it and say, okay, I came to this with a fresh mind. I understand exactly what's going on here. It's going to help me maintain this code. That's a good test worth keeping. Your tests are not special. They're not beautiful or unique snowflakes. They're the same decaying text as every other test. Fight Club again. Think about the team. That's what I want you to leave here with, I guess, more than anything else. Think about the team. Don't think about what you're doing in the moment. Think about the long-term value of that code. Think about maintaining that code a year from now. So that's really kind of the bringing all the talk together. I also am clearly passionate, if not angry, as you can tell, about bad tests. So I did write a book on it. You're welcome to check it out. And I also tried to finish up early so we could all get to lunch early, beat everybody else. But we have at least 10 minutes for questions.